We're looking at proving these three theorems, and all the three theorems, it is a similar kind of proof. So I'm putting it in same video. So first thing first, we're looking at the diagram. So in all of this, we are talking about a parallelogram. So we'll consider ABCD to be the parallelogram. And for all of this, we need to draw a diagonal, and that happens to be your BD. So let's begin with, let's consider a parallelogram ABCD join DB the diagonal. So that becomes your diagonal. Now what is that we are looking at? We need to prove three things. So let's look at the first one. A diagonal of a parallelogram or diagonal, single diagonal, divides it into two congruent triangles. So these two triangles are congruent. Triangle ABD is congruent to triangle ABD will be congruent to CDB. CDB. Okay, the order is important. Second thing, in a parallelogram, opposite sides are equal. So AB is equal to DC, and we have AD, which is equal to BC. Third thing is, in a parallelogram, opposite angles are equal. So angle A is equal to angle C, and angle D is equal to angle B. So this is what we are looking at. Okay, so let's begin with proof. So okay, I will give you guys a chance to pause and think over. If you're able to prove the first one, second and third is not that difficult. Okay, so we have in triangle ABD and triangle CBD, we have AB being parallel to DC. So what can you conclude about angle ABD and BDC? That they are equal. Okay, so we have angle ABD is equal to angle CDB. Reason, AB is parallel to DC, BD is the transversal line. So alternative interior angles are equal. So with this three reasoning, we can tell that these two angles are equal. We'll call it as X. Then we can tell angle ADB is equal to angle DBC. Let's call this as Y. So this is equal to this, and they are equal to Y. And we can also tell that DB is common. So we have two angles and an included side. So this implies triangle ABD is congruent to triangle CBD CDB because of ASA congruency. Okay, so the first part is done. What about the second and third? Since this is true, AB is equal to DC, then AD is equal to BC by CP CT. Okay, and also angle A is equal to angle C. This too is by CP CT, right? And angle ADC which is equal to angle ABC, since both are equal to x plus y. So we have the opposite side angles to be equal. Okay, so with all of this three proved, these three theorems are proved at one go. Okay, so it's not that hard. If you want to do it in any other way, we can do that. So this is convenient. You learn one method and it is applicable to three, so you can do that. Right? So pause and have a look.